Right, hey everyone. So this is going to be question number 7 on discussion, and it's going to be the function leaves, and what it's going to do is going to take in a tree T, and it's going to return a list of all the labels of the leaves of that tree. And so if we take a look at the doc test, the first doc test is pretty simple. We have a tree with the element 1, just the tree, like a leaf, with the value 1, and we know that's a leaf, so the return value of leaves is going to be a list of the number 1 because that's the only label and that's a leaf node. And as for the second doc test, if we draw this tree out, it's gonna look like a 1 right here. It's gonna be connecting to a 2, a 3, and a 4. Well, we know the 3 and the 4 are gonna be leaf nodes, and so that's why it's gonna return 3, 4. And so yeah, so if we think about like what we want out of this problem, we know that it's a tree. And so, with all tree data structures, there's like a recursive data structure. So we want to go through like recursion, and we want to recurse over each of the branches. And so let's think about what a recursive call on each of the branches is going to look like. And one thing to note about this function is that it's not mutative at all, because if we notice, leaves of tree is going to evaluate to something, and supposedly like just finding the leaves of that tree isn't going to mutate it. So we're going to be returning, we're not going to be mutating the tree at the very end. And so keeping that in mind, let's think about what a recursive call might look like. And so we make a recursive call on this branch right here. What do we expect it to return? Well, we expect it to return, a 2. Actually, we expect it to just return a list with the element 3, because we know that 3 is the only leaf in here. And so we got that down, and now let's think about, the other branch. And so if we make a recursive call on the branch 4 right here, we know that 4 is the only leaf in the tree, and so we should expect that to return the list 4, because that's the leaf. Same with the left side, 3. And so we know that we want to get the result 3 and 4, and so what can we do? We notice we have a 3, we have a 4 right here. We can take those and add it together, and that's going to be a result 3, 4. And so yeah, that's kind of going to be how we're going to handle our recursive case. And so we're going to make a recursive call on each of the branches, get their own like list of leaves, and then we're going to add that together. And we want to note that, since the top node, the 1, is not a leaf, then we know that 1 is not going to belong in this list of labels, in this list of leaves, because it has branches, so there's no way it can belong in here because it's not a leaf. And so yeah, along with that, I guess we can get started with our code. And so keeping that in mind, we can make a recursive call, and so it might be like leaves b. That might be a recursive call. Remember that we want to iterate through like each of the branches. It's like for b in t.branches. And remember that since we're not using like a lowercase tree, tree versus an uppercase tree. Remember that the lowercase tree is a data abstraction, and we got the branches, they're like branches of that tree. While for this one, it's a tree object, and we know that it's an instance variable, so we're going to access the branches through t.branches instead. And so we know that leaves of b is going to return like a list of all the leaves, and so we need like a list to accumulate all of the leaves of each of the branches. And so labels equals an empty list, and this labels is going to be like, so we're going to go through the first branch, we're going to get the 3, we're going to add it to the labels, so it's going to become like a 3, and then we're going to add the next recursive call into it, so like the list 4, and then we should get a result, and at the very end we should be returning it. And so let's make it labels equals this empty list, and then for b and t.branches, we're going to be adding the leaves of that tree onto the labels, and so labels plus equals leaves of b. And along with that, at the very end, we want to return labels. And yeah, so we coded up our recursive calls, but remember that we also need, our base case. And what is our base case exactly? And typically with like tree data structures, our base case is once we hit a leaf. Because once we hit a leaf, there isn't anything else to consider, because you have no branches to recurse on, and we're done there. And so what we can have is we can do like, if we have like the node 1, so this is a leaf right here. And what we can notice about this is that, it's a leaf and we want to include it in our like list of all the labels. And because of that, our resulting value of that is going to be like the list with just the element 1. And in particular, for any leaf with any value, it's going to be a list with just a single element of that value. And so we can code that up at the very beginning and say that if t dot is leaf, so if it's leaf, then we're going to return in a list with only one element, and that element is going to be t dot label, so the value at that node. And so yeah, I think that's going to be all of our program, and we can even run this to see if it works. Hopefully it does. Hopefully it doesn't error. But yeah, run the doc test, and looks like everything's okay. And yeah, that's going to be question number 7, leaves. And if you ever have any questions, feel free to ask me about it. And have a great day.